Hello, this is Dr. Michael Hassan, the Engineering Doctor, and this is lecture number 35. Flip-flops, characteristic equations, and modular flip-flops. Chapter 6, flip-flops of the course Digital Logic Design for Digital Systems or Digital Electronics. This is a disclaimer for you to read. I cite 3 references, however, there are many books in digital logic design. In Chapter 6 contents, we covered sequential networks, memory elements, the SR latch and flip-flop, the clocked SR flip-flop, the JK flip-flop, the T-type flip-flop, the D-type flip-flop. Today we'll talk about flip-flops, characteristic equations, and modular latches and flip-flop. Characteristic equations. A characteristic equation describes the behavior of the corresponding latch and flip-flop. It is directly derived from the latch of flip-flop truth table. The characteristic equation specifies the memory device's next state as a function of its present state and excitation inputs. Additionally, the characteristic equation is unique for a specific type of memory element regardless whether it is latch or flip-flop. It means it doesn't change. The latch, for instance, D latch and D flip-flop, they have the same characteristic equation. For example, the characteristic equation for the SL latch, master-slave, flip-flop, and clocked SL latch, or any other SL architecture is the same, is unique, is 1. By using these characteristic equations, it is usually possible to convert one type of flip-flop to another. And this is the beauty of the characteristic equation, allow us to do conversion from one type. So if it's one type is not available, we can derive it from an existing type with addition of some external gates, as we will see in a few examples. Now we derive the characteristic equation of the SR flip-flop Q plus is S or other prime Q. For the JK, Q plus is JQ prime or K prime Q. For the T, Q plus is TQ prime plus T prime Q. And for the D flip-flop, Q plus is equals to D. Q plus is equals to D. Now, we said we'll take a few examples to see the conversion. We'd like to show how to convert a D flip-flop into JK flip-flop. Well, just we equate the two characteristic equation. We say Q plus is equals to D, which is equal to JQ prime or KE prime Q. Hence, if we have a D flip-flop, we will derive the JK, okay, by placing the following circuit. We have 2 AND gates and 1 OR gate. So we need D to be equal to JQ prime. So we take Q prime and J to one AND gate. And we take K prime and Q to another AND gate. See, with feedback. And this will go to an OR gate, okay, because it's a sum of product, and to D. And the clock pulse is negative age triggered flip-flop. So here we have JK. We converted a D flip-flop to JK flip-flop as simple as possible. In example 2, we'd like to convert a D flip-flop to T flip-flop acting as a toggle switch. What does it mean, acting as a toggle switch? This is a beautiful example. If T is 1, Q plus will be T exclusive of the Q, which is equal to Q prime. Because T is 1 exclusive of the Q is a Q prime. Okay, by definition. You can prove it by simple truth table if you want to. So if the Q prime is equals to D, because Q plus is equals to D for the D flip-flop, so just to make a feedback here, a short circuit between a Q prime and the input D, and this will be a toggle flip-flop. A toggle flip-flop, a beautiful device if you like to a counter using D flip-flop. We'll talk about counters in the next chapter. Hence, the D flip-flop will D equals to Q prime is the T flip-flop acting as a toggle switch as shown here. Example number 3. Show how to convert a JK flip-flop into a T flip-flop acting as a toggle switch. For the T flip-flop to act the toggle switch, T is 1, hence Q plus will be equal to Q prime, which is equal to J Q prime or K prime Q. So therefore, J has to be equals to K, it has to be equals to 1. If Q plus is equals to Q prime, J has to be equal to 1, and K has to be equal to 1 because for the second term, K prime Q has to go to 0, so you will get Q prime. Right? Hence, the JK flip-flop with J equals to K is the T flip-flop acting as a toggle switch as shown. Just you take normal JK flip-flop with JK open circuited, or you take them to 1, and this will act as a normal T flip-flop as a toggle switch. An excellent device to counters. Now, characteristic equations are extremely important in designing sequential machines, and as we will see when we design counters and shift registers in the next chapter, and they are of great importance, as we said. Now we will talk about integrated circuit flip-flops or modular flip-flops. Okay, this stuff really you could find it anywhere in data sheet and for manufacturer's data sheet, or you can find it on the internet by simple searches, or there are many sites really specialized in integrated circuits basically. The 74279 is a quad S prime other prime large module. So there are 4 devices of 2 has S prime input, which is S1 prime and S2 prime, which the other 2 latches have 1 S prime. Each latch has a single output Q, so it does not have a Q. The 74LS73A is a dual negative edge trigger JK flip-flop with clear inputs. Does not have preset as only. The 74276 is a quad negative edge trigger JK prime flip-flop. It features common preset and clear control signals, and each flip-flop has individual excitation, input J and K prime. So we don't have K, we have K prime input. And this is very useful in some designs, okay? So if K prime is much simpler than K, so it would be much easier to derive, actually, as well as in non-negative edge-triggered clock. So it is a negative edge-triggered device. The 74111 is the dual JK flip-flop with data lockout feature that combines a positive edge-triggered master latch followed by a negative pulse-triggered slave. While the clock remains high, any changes to the excitation input are ignored, which is this is what's called data lockout. So it has a data lockout, so if the input changes, it will be ignored. When the clock signal falls, the new value in the master is gated to the slave. The 7473 is dual pulse-triggered JK flip-flop without a preset unclear, while the 74LS73A is a dual negative edge-triggered JK flip-flops. The 7476 is a dual pulse-triggered JK flip-flop with a preset unclear, and the 74H78 and the 74L78 are dual JK flip-flops with a preset common clear and common clock. It means there's one line for all the units. The 74LS78A is a dual negative edge trigger JK flip-flop with a preset common clear and common clock. The 7474 is a dual D positive edge triggered flip-flop with a preset unclear. The 7475 is a quad D latch module. It has 4 bistable D latches with enable inputs. The 74116 is a dual 4-bit hazard-free D latches with 1 clear and 2 enable inputs. So there are many integrated circuits for flip-flops or flip-flops as integrated circuits. We call them modular flip-flops. And you can use them basically to build any sequential circuits that you may need. This would be the conclusion of this lecture. Again, I would like to thank you so much for listening. Please subscribe and give me a thumb up. Okay, and to subscribe, just to click on the circle with letter I inside it. And hopefully to see you very soon in the next lecture. Sincerely, Dr. Hassan.